Hello and welcome to CodeChef. I'm Nandini Kapoor and today we are going to be discussing the problem named again XOR problem from the contest CodeDrive. Its prerequisites are that you need to know the properties of XOR, you need to know how substrings work, what a substring is essentially, as well as sliding window algorithm. Just a little bit of knowledge of what it is would be enough because I'll be explaining it how it is used in the approach. So let's move towards the problem statement and then we can go ahead from there. The problem statement essentially says that you are given a string s, its length is n, and you're given an integer k. Now you have to find the number of set bits in the XOR of all substrings of s that are of length k. A substring is a contiguous subsequence of a given string. So for example, if S0, S1, S2, S3, and S4 are the characters of a string, so obviously n being 5 in this case, then S0, S1 is a substring, S0, S1, S2 is a substring, but S0, S2 together, for example, S0, S2, this is not a substring, it's a subsequence. So it needs to be contiguous to be a substring. Also, it should be a substring of length k. So let's suppose k is 3. So the substrings of length 3 are going to be this as the first substring, this as the second substring, and this as the third substring. So if it isn't clear in the picture itself, their first substring is S1, S0, S2, the second substring is S1, S2, S3, and the third substring is S2, S3, S4. Now at S4 everything has ended, so we can't consider a new substring from S3 because then it will be S3, S4 and we have nothing else over here. So it will be of length 2. So these are the three, and their XOR, if it is, let's say 101, then there are 2 set bits in it. So our output must be 2 in that case. If it is 100, then there is just 1 set bit, so our answer must be 1. If it is 111, then the number of set bits is 3, so our answer should be 3. So this is what we need to output, the number of bits in the final XOR that are 1. Now XOR is performed on binary bits, so let us try to make something like a truth table, not exactly a truth table, but just to understand what the XOR is going to be. So 0 XORed with 1 or 1 XORed with 0 are both 1. When it is a 0 with a 0, the answer is 0, and when it is a 1 with a 1, the answer is 0 as well. So whenever the bits are same, the answer is 0, and whenever they are different, the answer is 1. In this case, we are not given bits, we are given a string. So 1 and 0 here are going to be characters instead of numbers. We'll see how we handle that in code. For now, just keep in mind that the XOR of character 1 with character 0 is a character 1. And we have to find how many characters are 1 in the final output, the final string that we obtain after XORing all of the substrings. Let us start building the approach with the help of the same example that we considered for the problem statement. So this is a given string, S0 up to S4 are its characters, N is 5 and K is given to be 3. And the substrings of length 3 that we were able to obtain are these 3. Now in the final XOR, the first bit is obtained by the XOR of 0, 1 and second indices occupying characters in the original string. The second bit in the final XOR is obtained by the XOR of the character at position 1 with the character at position 2 with the character at position 3 of the string. Similarly, the third bit is obtained by XORing characters at index 2, 3 and 4 of the original string. This bitwise XOR enables us to observe a pattern in the characters that we are going to be using in the final bits of our XOR. We observe that the indices of characters from the string that we are requiring for the calculation of every consecutive bit of the answer requires us to remove the very first character that was used in the previous bits calculation and add the character which is the immediate next to the last index that was used in the calculation of the previous bit in the answer. So we can take a look at this in the form of a window. As in, the first window consists of indices 0, 1 and 2 from the string. The second window consists of indices 1, 2 and 3 from the string, which means that it has been slid by one index. You can understand this better using this diagram, in fact. So the first window covered 0, 1 and 2. Then we slid the window by 1. So now 0 has been excluded and 3 has been included in it. Now, this being the last substring of length k that we were able to obtain, we can observe that our first window of indices in the string extends from the very first character up until the very first character of the last substring that we were able to obtain. In this case, it is S0 to S2. In a more generalized manner, it would be from 0 to n minus k, which means the size of our window is going to be n minus k plus 1. The brute force approach of implementing this that comes to mind is to just iterate over each and every single one of the windows and find the XOR to conclude whether the bit in the final XOR will be 1 or not. However, if we do use this approach, we are not making use of the sliding windows at all. The advantage of having a window is that some part of the window in consecutive windows is always common. So you need not calculate this common part over and over again, you can reuse it. Now we'll use some properties of XOR to ensure that we are removing the first element of the previous window safely. If this is our first window, then to get rid of the S0 for the second window, we would XOR this with an S0. As we know the property of XOR, a number XORed with a number, the same number, is always going to be 0. The examples are the bit 1 XORed with 1 is always 0 and 0 XORed with 0 is also always 0. So thus, XORing it with S0 gets rid of the S0 and instead replaces it with a 0. What is another property of XOR that can help us here? Any number XORed with 0 is that number itself. The examples are 1 XORed with 0 is 1 and 0 XORed with 0 is 0. So they're both the first number as the answer if we have XORed them with 0. So if we call this x1, then x1 XOR 0 is what is remaining with us, and this will give us x1 itself. So what do we have here? The evaluated common part of the windows. Now all we need to do is XOR it with the next element and we have obtained the next window. So if we XOR it with Sn minus k plus 1, now we are at the second window that we need. If we try to generalize it, let us say Wi is the ith window. So by observing the pattern that the 0th window extends from 0 to n minus k, first window extends from 1 to n minus k plus 1, we can say that the ith window extends from Si, that is the ith character, up to Si plus n minus k. To obtain the I plus 1th window, that is the immediate next window with the help of Wi, we need to XOR it with Si, that is the first character in the window, because we need to get rid of it for the next window, as well as the immediate next character to the last character in the previous window, which means the immediate next character to this So this would give us our I plus 1th window. Now we have the formulas and we have gone over how we are going to approach the problem. Let us take a look at how we are going to actually code it. So the first few lines in the code are for taking the input in the format in which it is given. Apart from that, we are declaring a variable to store our answer, which is the number of bits which are set in the final XOR of all substrings of length k. It is initialized by 0 because we'll increment it as we find that the answer contains 1 as the ith bit. Now XO is a variable that stores the XOR of the current window. This loop finds the first window's XOR. So the first window extended from the index 0 to the index n minus k. It was of size n minus k plus 1. We have seen this in the approach already. So this is the calculation of the XOR of all characters in the first window. If this XOR is 1, that means the first bit of our XOR of all substrings is going to be 1 as well. That means it is going to be set, and so we increment the answer. There are also two variables, namely indbeg as well as indend, which store the indices of characters which we need to include in our window and exclude from our window. So beg stores the index that we need to exclude from our window, and end stores the index of the character that we need to include in our window. Now the first window started at 0, which is why when we move on to the next window, we need the characters at index 0 from the string removed from this window, which is why beg starts from 0. Our first window ended at n minus k, which means the character that we need to add is the immediate next of n minus k, which is n minus k plus 1. So for the next window, we need to add this character to the window. That's why that is the value of our end variable. Now inside the loop, what we are doing is we are taking the current XOR, that is the XOR of all characters in the current window, and we are XORing beg, the character at index beg, with it. So this gets rid of the character at index beg, that is the first character in our previous window. We also XOR the character at index end to this. What this does is adds the immediate next character to the last character in our previous window into the XOR. So now what is in XO? XOR of our current window. If this XOR is 1, then we know that the bit in the final XOR of all substrings is going to be 1, and so we increment our answer. We continue this process for as long as end is less than n, because once it exceeds n or is equal to n, the substrings that we start obtaining will be of length less than k. So as soon as we are out of the loop, we print the answer. From what is written on the whiteboard is just the same thing that I just explained, which is inside of this loop. So our previous window is from character beg to character end minus 1. To obtain the next window from this, we XOR it with character beg as well as character end. So this gives us the substring from the XOR of characters from beg plus 1 to character end. That would be our current window. So we have obtained the current window from this previous window. The complexity of this code is big O of n, because we iterate from 0 to n minus k in this loop, and then from n minus k plus 1 up to the entire end of the string, that is n, we iterate through this while loop. So all in all, we have iterated from index 0 to index n. So big O of n, we are not taking any more complexity attributed to k or attributed to calculating the windows separately. That's about it for the question. Thank you for watching. Do like, share, and subscribe if you did like the video, and leave suggestions down in the comments.